that's why I have you write this. It's what you learn first, and it's how you read, right, left to right. So going from position to velocity is derivative, going from velocity to acceleration is the derivative. If you go backwards, that's what you learn second in calculus, which is the integral, also called the antiderivative, okay? Because you're going against the derivative, right? Personally, I think antiderivative sounds precocious when I say it, so I always call it the integral. Okay. So, the difference between calculus and physics is in AB calculus, you guys only do one dimension. So you'll have a particle that's moving either horizontally, and that's it in calculus, or you'll have a particle moving up and down, and that's it. So AB calculus keeps the PVA problems very, very simple. You will probably in calculus have 4 or 5 multiple choice questions on PVA and probably 1 free response on PVA also. So of your 6 free response questions in calculus, you'll have 1 PVA most likely, because that's what they usually do. Okay. So because you're taking both, it's good because it's overlap, but what they ask is a little bit different. In physics, we do both things. So we take velocity vectors in the x direction, velocity vectors in the y direction, and then how do we put them together? With Pythagorean theorem, right? So the stuff you see in AB calc is simple, it's just one-dimensional motion. Physics is the same thing, that just looks harder because it's going at an angle, right? But really, if you just break it down to x components and y components and then use Pythagorean theorem to put them together, it's basically the same thing. It just looks more complicated, and the motion looks more complicated. So, when you see this type of problem, again, I would recommend you write that so that you can remember which way to go. I can tell you that most of the time, they're going to give you the velocity. And most of the time, they give you the velocity because then they can ask you to take a derivative going this way and an integral going this way, right? So most of the questions you'll see on the AP exam, they're going to give you the velocity, especially in calculus. They pretty much always give you the velocity that way. All right, so let's see what you can do. We're going to look at this first packet. We're actually going to go to number 12, which is the guy pulling the box. Go ahead and read the stem real quick. And you should notice that they gave you an equation for what? Position. So x equals 0.5 t cubed plus 2t is your position, right? And then part A wants you to find what? Speed. So how do you go from position to speed? Derivative, just once, right? Okay, so go ahead and take the derivative of that. Okay, good. It looks like most of you know how to do the power rule for the derivative, right? The only thing I did see as I was walking around is your notation. So notation is important on not only the physics test, but also on the calculus test. So what you want to write is the speed or velocity v of t is equal to, you always want to show how you got that, and that's the derivative of position. And then take the derivative, so put the 3 out front, that's 1.5 t squared plus 2. Okay, so notation is super important on both tests. I always recommend you do it generically first, and then what do they tell you to plug in for t?
0.
0. So the velocity at 0 is equal to, plug in 0 to get. And then units are also super important. So the position was in meters, so the velocity will be meters per second. On the AP exam, both of them, you get points for taking the derivative, and then you usually get points for the answer too. So it's super important that you show your work on all of them, step-by-step process, especially if you're one of those people that can get lazy and not show your work. You get points for showing your work on both tests. All right, part B, determine the following as functions of time, find the kinetic energy of the box. And here's some formula charts just in case you need to look up a formula. Be careful, they said, determine the following as a function of time, which means what? Means you actually have to leave t in the answer as your only variable. So you're not actually going to get a numeric answer in this case. So kinetic energy is 1/2 mv squared. So the mass they told you was 100, and the velocity was 1.5 t squared plus 2, and squared. And you can leave your answer like that. All right, part 2, find the net force acting on the block. Remember, this is a PVA problem, right? So to find the force, what do you need to find?
Acceleration.
The acceleration, how do you get the acceleration if you have the velocity? Alright, so to go from velocity to acceleration, you take the derivative, so it'll look like this. A of t is equal to v prime at t, and the derivative 1.5 t squared is 3t, and the derivative of 2 is 0, so you just end up with the acceleration is 3t. Then you can plug that into sum of forces equals ma, and the mass is 100, and the acceleration is 3t, so it's 300t. Am I done?
Yeah.
No, because what did I not put on my answer? But I always need to in physics. Units, so the acceleration will be what units? Meters per second squared. A lot of times on the calculus problems, they don't mention limits at all, so you don't have to put them on in calculus unless they mention them. But in physics, they're always going to mention the units.
That question was
Yeah.
net force acceleration.
What's that?
My question was net force and acceleration. So it should be newtons.
Oh, yes, thank you. Force, thank you, newtons. Sorry, long one. Acceleration is 3t meters per second squared, thank you. All right, turn to page number 3. Find the power being delivered to the box. And if you look at your formula chart, how many equations do you have for power? 2. So I actually want you to do it both ways, one with calculus and one without. For the EDT, the change in energy over change in time, you're gonna use the kinetic energy from part B and take the derivative of that. All right, let's do the non-calculus one first. So, what we've already done, the force is 300t, and the velocity equation was 1.5 t squared plus 2. And I'm going to go ahead and simplify this one by distributing that to both of those. So 300 times 1.5 is 450 t cubed, and 300t times 2 is 600t. And then for the calculus one, I saw at least one person did it right, but a lot of you didn't. We take a derivative. I always say you got to follow the rules. So what rule do you have to follow in this case? Chain rule, right? Because you got an outside part and an inside part. So when you take a derivative, the coefficient stays there, and then you're doing chain rule on this part, and you do the outside first, which is the power. So you do the power rule. So the 2 comes out front. As you're doing the outside, the inside part stays the same. You subtract 1 from the exponent, which is 1, which obviously you don't have to write. And then times the derivative of the inside. So this is another power rule. So the derivative of the inside is 3t. Chain rule will be all over your calculus test. Might see it once on the physics test. And then if I take this, which is 100 times that by that, that's 300t times this is what I ended up with right here. So that just shows you that you're going to get the same thing. And power is in what units? Anybody?
Is it watts?
Yeah, watts. All right, for C, calculate the net work done on the box. So if you take a look at your formula chart, what formulas do you have for work? Actually, it's one and they put it together. So work is equal to,
We haven't learned what that little symbol is.
what the little delta is?
They're not delta, but.
Oh, the integral symbol? Yeah. So on your formula chart, you got delta E is equal to work. That's the non-calculus way of doing it, and then the calculus way is the integral of F dot dr. So do it with work is change in energy. And don't forget you have a velocity equation, that's a function of time, so you're gonna use that to determine your velocities at the 0 and the 2 seconds that they're worried about. Alright, so if this is our velocity equation, what's my velocity at 0?
2.
Meters per second, and plug in 2, and you get
8.
8 meters per second. So work is change in energy. The only energy we're worried about in this case is what? Kinetic energy. So it's going to be the final kinetic energy minus the initial kinetic energy. it's 1/2 times 100 times final is 8 squared. 1/2 times 100 and 2 squared. Plug that in your calculator, do your mental math, and you get 50 times 60, which is 3,000. And work or energy is in what units?
So it should be 50 times 64.
So, oh, I put it together. So this is 50, which is common, which I pull out, right? And then this is 64 minus 4, which is 60. Sorry, I jumped ahead on my math. If I had to do this without a calculator, I'd factor out the half and the 100, make it 50. Do it that way. It used to be you could not use a calculator on the whole Physics C exam, but they changed that a couple years ago, so you are allowed to use a calculator on the whole test. And units for work or energy? Joules. All right, go ahead and read D. All right, so is the work done on the box by the student greater than, less than, or equal to what you got in part C? The actual work done by him? Less than why?
If we didn't take into account friction.
Okay, you do have to take into account friction. Does friction cause him to do more work or less work? More work, so your justification is right, but your answer was wrong. So, correct answer is greater than. Because friction is doing what kind of work, positive or negative? Negative, so I would say something like, since the box is on a rough surface, friction does negative work. So, work net is equal to the work done by the student minus work done by friction. Or if you rearrange that, the work done by the student is equal to the work net plus work done by friction. So since you're adding that, it's going to be greater. All right, so what makes that a hard problem? It covers just about lots of different things, right? So we started off with a PVA or a motion problem, then we talked about forces, and we talked about energy, then we talked about work. That's what to expect on the AP exam, is the free response questions are gonna cover, a multitude of different things that you cover in this class. Okay? So how do you approach it is you do the ones that you know how to do, and you don't get stuck on one that's gonna cause you to stare at it for too long a period of time. What makes this a hard test, in my opinion, is the time crunch. So the nice part is it's an hour and a half, boom, you're done. The hard part is getting 35 multiple choice questions done in 45 minutes and 3 full free response questions done in 45 minutes. So don't get stuck on one. Don't be afraid to just move on. The nice thing about physics is the bar is not set super high, even for getting a 5. So it's something that's very attainable, and a 3 is very, very attainable. You just don't want to get stuck and be one of those people that can't move on from a problem because you just have to solve it. And on the test, you just got to be willing to move on. Okay? And if you know you're not good at a topic, don't be afraid to skip it in multiple choice and come back to it. Or when you get to the free response questions, look at all three of them, go, oh, hey, I know how to do this one. I'm really good at this one, so I'm going to do this one first. Get all those points. And then the ones that are harder, get to them if you possibly can. Personally, I always tell my kids, I don't even know if I could finish that physics C test in an hour and a half. Calculus, no problem, I can do that any day, but physics C is, the time crunch is definitely what makes it a difficult test. And just the fact that you're moving back and forth from topics. Okay? So I recommend you memorize as many of those formulas as you can. Even though this is a crutch, which you can now use on the entire test, it takes time to flip back and forth between the formulas and stuff. So if you're somebody that has to look up kinetic energy as 1/2 mv squared, you're probably not going to pass, unfortunately. So memorize the big ones, and then if you just happen to forget, it's a crutch that's there for you. All right, let's do the first one that looks like this. So you have a particle moving along the parabola with the equation y equals 1/2 x squared, as shown in the figure. This is a multiple dimension motion problem, right? So we're going to have to break this up into x and y components. So suppose the particle moves so that the x component of the velocity has a constant value of vx is equal to c. That is, x is ct. They actually asked this one on the diagram above, indicate the direction of the particle's velocity vector v and the acceleration vector a at point r, and label each vector. Personally, I would not have written this question this way because I think it's better to answer part 2 and 3 first and then go back and put the vectors on, especially for the acceleration one. So let's start with part 2. Determine the y component of the velocity, the particle's velocity as a function of x. is a PVA problem. Okay, now I just want the velocity in the y direction component. So what do I know about y? Or, let's start with, how do I get the derivative of, how do I get the velocity in the y direction? It's the derivative of what?
Is 1/2 of 0.
Yeah, the y equation, right? So, that's the derivative of the y component, which is just what? So the derivative of y or dy dt is equal to just x. Oh, wait. Okay, so that's just x. Can I do it that way, though? This comes to a calculus thing. dy dt means I'm taking the derivative with respect to what variable? T, right? And y equals 1/2 x squared has no t's in it, right? Agreed? So, have you guys done implicit differentiation in calculus yet? Okay. This will be a little bit more confusing then. So, I want to do this. Let's do this. Let's replace x with what x is equal to. So, x is equal to ct. And then I don't have that problem because now I just got rid of my x and did it in t, terms of t. So, PVA problems are always with respect to time. So when I take the derivative of this, what rule? Chain rule. You got an outside part and an inside part. So a half stays, do the outside part first, that's power rule, so 2 comes out front, inside stays the same, subtract 1, you don't have to write, times, let's derive ct, c is a constant. Just C. So the velocity component is c squared times d. And they did not give you any units on this problem, so you don't have to worry about units. All right, now that that's my velocity, find the acceleration in the y direction. Remember, c squared is a constant. It's not a variable. So remember, I'm always going to show how I got it. So the acceleration in the y direction is the derivative of velocity in the y direction. This is a coefficient, so it just stays there, and the derivative t is just 1. So the acceleration in the y direction is just c squared. All right, so I can draw my acceleration vector back in part 1, or I. What's the acceleration in the x direction equal to? velocity in the x direction is just c, which means the acceleration in the x direction is 0. Because this is just a constant, so the constant is 0. All right, now go back to the drawing and draw your velocity vector and your acceleration vector on that graph. And this is a graph of the particle's position. If that helps. This is position. How do I go to velocity? Derivative. You know how to get derivative from a graph? Slope of the tangent line, right? So the velocity vector will just be tangent to this graph. So that's how you always get a derivative off a graph, is slope of the tangent line. And then the acceleration vector, because the acceleration is 0 in the x direction and c squared in the y direction, which way does my acceleration vector go? Straight up. Good, straight up. So on a position graph, the velocity vector is always going to be tangent. The acceleration can change depending on what the accelerations are, the components are. All right, go ahead and turn over part B. Suppose instead that the particle moves along the same parabola with a velocity vector whose x component is given by Vx. Is equal to c over the square root of 1 plus x squared. Supposed to show that the particle speed is constant in this case. So because I have an x component and a y component, how am I going to get the resultant component? Pythagorean theorem again. I am going to have to teach you how to do this though, because we're not going to be able to plug in for x. Probably. Alright, that other problem that I kinda cheated on, when we had this, right? The last time I just plugged in X was CT, but in this case, we don't have what X is, so I'm gonna have to show you how to do this. So I can take the derivative of this with respect to X, right? So the derivative of this with respect to X is just X. The 2 comes out front times a half is just 1, X to the first. But what I really want is the velocity in the y direction, which is dy dt. So to do that, if I have dy dx is x, if I have this, what do I multiply by so that I end up with this? This is a form of the chain rule. So I want the dy on top, right? And it's already there. I don't want this on the bottom, right? So how do I cancel that out?
Would it be dx over dt?
Yeah, I'm sorry. I don't want this on the bottom, yeah, so it's dx, but I do want this on the bottom, so dx dt. Okay. And then the dx is canceled, and that'll give me what you want. That's a form of the chain rule. And they do ask that on the calculus test sometimes. Alright, so I know dy dx is x. Dx dt is the same as what?
Just be.
This is change in x, which is a change in distance or position over change in time, and position over time is also called velocity. So this is the velocity in the x direction as well, which I have. So the velocity in the y direction is x times all of that over there. And then once I have those two things, I can do Pythagorean theorem to get the resultant velocity vector. So B net is going to be the square root of Vx squared plus Vy squared. And I'll give you a second to see if you can do that math. Alright, so when you plug it in, if you square this, top becomes what? You squared, bottom becomes 1 plus x squared. Square cancels the square root. Over here, square the top, you get c squared x squared. Bottom, again, cancels out the square root.
Excuse me, we have an announcement and then we will switch to our next class. We have our first round of gift card winners. Those students that are announced can report to the center hallway to the library. Bailey Scott, Haley Blondo, Amber Daniels, Olivia Williams, Kajan Scott, Kylie Stringer, Gurpreet Kaur, Bailey Abear, Kylie Prestridge, Sydney Forbes, Kayloni Bowden, Elizabeth Barrett, and Ashley Horton. At this time, you can move to your next class.
So you already have common denominators, so you can add them together. You can factor out a c squared on the top. That'll leave you with that. And then those cancel, and the square root of c squared is. That just proves that it's a constant. Alright, then just finish this problem really quick. The velocity vector for number 2 is still going to be what? It's going to be tangent. So the velocity vector is still tangent. But because you have a constant speed, the acceleration is going to be perpendicular. Because then that would cause circular motion. So you can have constant speed in circular motion where the acceleration is just pointing straight towards the middle or center. All right, go ahead and take a little mental break.
Yeah.